Hello class, for today's lesson is about solving real-life problems with quadratic inequalities. And here are our learning targets. First, I can solve problems that involve quadratic inequalities. And next is I can explain what the solutions to the quadratic inequalities mean in real-life situations. For our first problem, we have here a rectangle has a width of x meters and a length of 12 minus x meters. If its area must be greater than 30, which inequality represent the situation? So first, just like what we had in quadratic equation before, we need to interpret and know the given on what they are. So going back with the area of a rectangle, so we have it here. Area is equal to length times width. Based on this, our length is 12 minus x, and our width is x. So that's it. Now, an area here, as you can see, is associated to equation. But then again, our topic is about quadratic inequalities. So instead of having an equation here, we are going to take count on what is the given situation. So it must be greater than 30. So based on that, we could write here. So for our area, we have L times width. So 12 minus x times x. And again, it says here the area must be greater than 30. So we could just write here greater than 30. And to simplify, we have here x times 12 and x times negative x. So we have here 12x minus x squared is greater than 30. But to write this properly, according to the ax squared plus bx plus c is greater than, or it could be less than, greater than or equal to, or less than or equal to 0. Anyway, let's just stick to this first. So we have here, so let's have our negative x squared to be written first according to the standard form. So we have negative x squared plus 12x is greater than 30. So during the exam, I may give you items or choices having this as the answer, or I might also give this one, negative x squared plus 12x. So when we transpose positive 30 to the other side, it will become negative 30. So negative 30 is greater than 0. So either of the two, I'm gonna accept both answers, so don't worry. So based on the problem here, here are our final answers. That's it. For our second problem, we have an object is dropped from a building and its height after t seconds is given by h of t is equal to negative 5t squared plus 40. For safety, the height must stay at least 15 meters above the ground. What inequality models the situation? Now, we need to know or highlight the given. Here, we have height. We have here height after t seconds, in which it is here at least 15 meters above the ground. And based on the problem, it is asking for the inequality models. So we are going to involve the interval notation or the inequality form. Now here, let's go back to writing. Now, let's rewrite. We have h of t is equal to negative 5t squared plus 40. Now, again, we are gonna rewrite this into negative 5t squared plus 40 because we are gonna comply or satisfy the given problem in which this expression here should be at least 15 meters above the ground. So when we talk about the word at least, sorry, let's choose other color. So when we talk about the word at least, it means that 15 is also included, so it is equal to 15. And we also have above the ground, so we're going to use greater than or equal to 15. Now, just wait for a while. Okay, that's it. Now, let's simplify this first accordingly. So, by the way, this is your first step. So, what do you call this? You are going to translate the given problem into the right quadratic inequality. Now, let's go back to solving this. Again, we are asked on the models. So, when we talk about the models, it is either, or you write either of the two or both of them, the quadratic, the inequality form, or interval notation. So first, let's transpose 15 to the other side. So it will become negative 5t squared plus 4t. 15 here will become negative 15. So we have minus 15 is greater than or equal to 0. So negative 5t squared 4t minus 15 is positive 25 is greater than 0. So based on this, we could factor the given expression. So we have 25, right? I think the easy method for this one would be extracting square roots. So we have here negative 5t squared. So we're going to transpose back 25 to the other side. So it's greater than or equal to negative 25. So first, our goal in extracting square roots is to make sure that our variable here will have a coefficient of 1. But since it's not 1, then we need to divide both sides by negative 5 and negative 5. Okay, so here we could cancel negative 5 and negative 5. So we are left with t squared is greater than or equal to negative 25 divided by 5 is 5. Now, in extracting square roots, we need to do the square root sign. So, extract the square roots of both sides. So, I have here square root of, square root of. So, cancel 2 and the square root symbol. So, we are left with t. So, t is greater than or equal to positive and negative square root of 5. But then again, here we need to make this or write this in an inequality form and interval notation. Now, to write the values of t or the critical values of the quadratic inequality given, so let's just write it properly. We have t is equal to square root of 5 and t is equal to negative square root of 5. So in our number line here, we have 0 and square root of negative square root of 5, right? Negative square root of 5, and we also have square root of 5. Now, approximately negative square root of 5 is negative 2.24. And for this one, we have we have positive 2.24. Let's extend the number line first so that we could illustrate it properly. So, since we are aware that the approximate value of square root of negative square root of 5 is negative 2.24, so the number before that we could choose negative 3. And for this one, we could also choose 3. And since this is at least 15, right, based on the given, here we have the greater than or equal to, which means the critical values negative square root of 5 and square root of 5 are included or could satisfy the given problem. So let's see if the numbers in between or after or before would satisfy the given inequality. So let x be 0. Going back, we have negative 5t squared plus 25 is greater than or equal to 0. Now, if we let x be 0, so we have it here, negative 0 squared plus 25 is greater than 0, which means the result of this is 25. Is 25 is greater than 0, which is actually true. So the middle values, or the values between negative square root of 5 and square root of 5 are correct. Now, to see if the numbers before negative square root of 5 and the numbers after square root of 5 would satisfy, let's check. So let x be negative 3. So negative 5 times square root of 3 squared plus 25 is greater than or equal to 0. So you have here negative 5 and then 9 plus 25 is greater than or equal to 0. Negative 5 times 9 is negative 45 plus 25 is greater than or equal to 0. Based on this, we have negative 20 greater than or equal to 0, which is wrong. So the numbers before negative square root of 5 do not satisfy the given inequality. But let's also check the other side. So let x be 3. So negative 5 times 3 squared plus 25 is greater than or equal to 0. We still have the same thing here. So 9 plus 25. So we have negative 45 plus 25 is greater than or equal to 0. But still the same thing. It's negative 20 greater than or equal to 0, which is still wrong. So the only thing that applies here are the numbers between negative square root of 5 and square root of 5, including both numbers. So when we write it in an interval notation, we could write it like this. So we have it here, the bracket, because again, negative square root of 5 and square root of 5 are included. So negative square root of 5 and square root of 5. And this is our answer for the interval notation. Okay, on top for the inequality form, so we have here x is greater than or equal to negative square root of 5, but less than or equal to square root of 5. And that's it for number 2. For our third problem, we have a company estimates its profits in thousands of pesos as P of x is equal to negative x squared plus 14x minus 40, where x is the number of items produced. The company wants a profit of at least 20,000 pesos. Which inequality describes this? Now, let's highlight some words here. We have a profit and at least 20,000 pesos. Now, since when we talk about profit, obviously it goes up. So automatically, we could have greater than symbol. And you also have at least here. Again, when we have the word at least, it includes itself. So when you write it this way, from P of x negative x squared plus 14x minus 40. So we could rewrite it into negative x squared plus 14x minus 40 is greater than or equal to 20,000. Now, we could transfer or transpose 20 to the other side. So let's just make the right side 0. So we now have negative x squared plus 14x minus 40 minus 20 is greater than or equal to 0. So negative x squared plus 14x minus 60 is greater than or equal to 0. So this is our new inequality now. So in looking for the critical values of x, we could use any method. It could be factoring, extracting square roots, quadratic formula, or completing the square. But based on this, I think I'm gonna use quadratic formula. But before I'm gonna do everything based on the quadratic formula, I'm gonna look for the discriminant for me to see if the answer is real or not. So for the discriminant, if you could still remember, it is just based on the b squared minus 4ac. So our discriminant, again, the nature of our discriminant will tell us if our values of the variables could be real and equal if our discriminant is 0, and real and unequal or distinct if it's not 0, and imaginary if the result of the discriminant is negative. So based on this, let's identify first the A, B, and C. For A, we have negative 1. For B, we have 14. And for C, we have negative 60. Now, let's go over to the discriminants formula. So we have here the discriminant, we have b squared. So we have 14 squared minus 4 times negative 1 times negative 60. So 14 squared is 196. We have our negative times negative times negative is negative, because again, negative times negative is positive, but positive times negative is negative. So minus. So 4 times 1 times 60 is negative 240. And 196 divided by 240 is negative 44. Since negative 44 is imaginary, which means for the given problem, we could say that there is no real value of x. The real value of x makes p of x, which is greater than or equal to 20. And this is our answer for problem number 3. Now dito, what if the discriminant is 0 or any other number except for negative? Then based on that, we could continue in finding the critical values of x. But based on this one, since this is negative, so that's it. No real value of x makes p of x is greater than or equal to 20. For our last problem, we have a playground is to be fenced on 3 sides along 80 meters of fencing, with a 4th side along a wall. If the width is x meters, then the length is 80 minus 2x. For the area to be at least 600 square meters, what inequality describes the condition? So again, let's talk about area again. So length times width. So based on this, we could write x times 80 minus 2x is greater than or equal to 600. We're still using greater than or equal to symbols because it says here at least 600 square meters. And we're talking about fence. So obviously when we talk about fence, it's going up, it's high. So that's why we use greater than symbol. I don't know if there are any infrastructures in which a fence is to be viewed as going down. However, generally it's going up. That's why we use greater than symbol. And at the same time, the equality symbol or the equation, because of the at least, in which what do you call this? In which the 600 is to be taken account of as well. Now, based on this, we could distribute. So we have 80x minus 2x squared is greater than or equal to 600. Now, as we transpose 600, it will become, let's rewrite this properly na lang. So we have 2x squared, negative 2x squared plus 80x, and then 600 will become negative 600 is greater than or equal to 0. Now, based here, in finding the critical values, we may now, you may now use either factoring, extracting square roots, completing the square, or quadratic formula. But based on this, I'm gonna use factoring. So for this one, I'm gonna have AC method. So for this, I'm just gonna multiply negative 2 to this one. So we have x squared plus 80x, and then negative 2 times negative 600 is 1000 plus positive 1200. Again, it's just my choice, so whatever method you're comfortable with of using, then do your thing. So you have here 1200. So I'm gonna find numbers that would potentially get to 1200 and will eventually have my bx as 80. And with that, I'm gonna use 60 and 20 here. So since 60 plus 20 is 80, which means it satisfies the given bx. Because then again, 60 times 20 is 1200. But since I'm using AC method, it doesn't stop there. We should remember that our a is negative 2, so we should divide both sides by negative 2. So 60 divided by negative 2 is negative 30, and 20 divided by negative 2 is negative 10. Doing the lazy method for the values of x, okay? So negative 30 will become positive. Same thing with the negative 10. So here are our critical values. So in the number line, we could have it like this. So 10, 30, and let's have one number in between. So 20, and one number after 40, and one number before. Let's use 0. Since this is a greater than or equal to symbol, so we need to include 10 and 30 despite being our critical values. So this time, let's check whether the values in between them or the values after or before would satisfy. So that in order for us to get into the interval notation and inequality form. Now, let x be 20. So we have again negative 2x squared plus 80x minus 600 is greater than or equal to 0. Based on this, I'm just gonna substitute 20. So negative 2 times 20 squared plus 80 times 20 minus 600 is greater than or equal to 0. I'm just gonna use my calculator since you're also allowed to use it. So based on this, we get 200 as a result, and 200 is actually greater than or equal to 0, which means the numbers in between 10 and 30, including 10 and 30, would satisfy the given inequality. So this one is correct. But let's also try the numbers before and after. So let x be 0. So this one is a number before 10. So we have negative 2 times 0 squared. What was that again? Plus 80 times 0 minus 600 is greater than or equal to 0. Based on this, we could just cancel this one and this one, and we are left with negative 600, which is actually not greater than or equal to 0. So the numbers before 10 would not satisfy. And just to check, let x be a number after 30, so we could use 40 here. So we have negative 2 times 40 squared plus 80 times 40 minus 600 is greater than or equal to 0. So let's use our calculator here. So based on this one, the result for this is negative 600, which is not greater than or equal to 0. So based on our findings of the checking, we could say that the interval notation is only exclusive to the numbers 10, including 10, going to the values up until 30, including 30. And when we write it in inequality form, we have x is greater than or equal to 10, but x is less than or equal to 30. And that's it for today.